Okay, so this is picking up where we left off last time in the middle of factoring out a negative, right? All right, so we factored out a negative. Do you remember how to complete the square?
Yes.
Some people say yes, some people say no. Okay, so Michaela, you said yes. What do I have to do?
Divide the 4x by 2. Right?
Okay, so the key idea is to take the middle term. In this case, that's a negative 4. Divide it by 2.
And square that.
And square that.
Add it to the...
Okay, so let's find out what this number is first. What number is this if I divide it by 2 and square it? This one happens to be a 4. So they don't usually match, but if you've got a 2 involved, they will. And then Michaela says I should add that, and I do. I add that right there. But you can't just go adding things in the middle of problems you're working, or it makes things unequal, right? It's like when my kids add something to my grocery basket, the bill will not be the same. Okay? This doesn't work. So somehow we have to compensate for what we've just done. And the compensation will occur outside the parentheses, but you have to recognize what you really did, because you really did not add 4. What did you really add? Negative 4. Why, Jordan? We factored out a negative. There's a negative in front of that 4. Way on the outside of those parentheses, so we didn't really add 4. We added 4 inside of a parentheses that had a negative on the outside. We really added negative 4. So our compensation sort of looks like, in this case, I'm adding 4 again. I'm not, right? Because the first time I really added negative 4.
So what if you had like a negative 2 on the outside? It'd be negative 8?
Yes, so you would add 8 on the outside. So whatever you have on the outside is going to act upon what's ever inside. So like Janet asked, if I had a negative 2 here, then everything inside would in fact be multiplied by negative 2, including the plus 4 I just added. So that plus 4 would be multiplied by the negative 2. I really changed my equation by negative 8, which would mean then I would add 8 on the outside. So far so good? Okay. Let's find a way to rewrite this so that it's actually usable now, because it's still not quite in the form we need. The form we need actually needs the constant at the front. So I'm just going to put that plus 4 and I'm going to move it to the front. Okay? So I'm going to put this as 4 in the front of my equation, or my expression. I've got that minus. And then what I really want is I really want this in factored form. I want it as something squared. And I can get it as something squared because that's what completing the square does, is it allows me to put it as something squared. Well, the x is a given, right, because that's up here as x squared. And then the last term should be the square root of the 4 that I added, which would be 2. So this is 2. What sign goes in between? Minus, because I have a negative 4 in the middle of my problem. Okay? So this right here is equivalent to the original denominator I have. So my original problem can now be rewritten underneath the square root as 4 minus the quantity x minus 2 quantity squared, dx. I want to see those dx's on your problem too until you integrate, okay? So this is actually what the problem becomes. We did one that looked almost like this already. The problem's not difficult from here. It's the algebra completing the steps part that makes the problem a little bit weird or different, okay? So let's take this and we're going to actually integrate now. All right, so the first thing I'm going to do is I'm going to identify what my u, or my a is, excuse me. What is a in this problem? It is 2. And again, that's just for the purpose of using the formula that I'm identifying a. It's not for the substitution, because I also need to use substitution. What's my u? X minus 2. And my du? 1 dx. Lovely. So I can take this now and rewrite it with the u in and with the a identified. So this will be the integral. I'm going to put the 2 on the outside just because I like to do that. You don't have to. And then I've got the square root. That 4 is really 2 squared, right, as a part of my formula, minus u squared. Dx is equivalent to du, so it simply gets replaced. So I'm going to put my 2 down from the outside. And my antiderivative of 1 over the square root of some stuff here is actually which trig function? Arc sine, which we identified before. of u over 2 plus c. Thank you. There's a 2 here. There's an arc sine still present. And then what I really need is I need that u to be x minus 2 over the 2 plus the c. Let me make a comment of what some people sometimes try to do when you get here. People do it in trig, and I suspect somebody's going to try and do it if I don't tell you not to, so I'm going to tell you not to. That 2 and that arc sine can't sort of distribute through. Okay? That's not an operation that will work. It will give you the wrong value. It did in trig and it will in calculus as well. Okay? So you can't combine the 2 on the outside and combine the values inside, because the values inside are acted upon by another function, the arc sine function. So you can't do any sort of moving things through. Just kind of like when you can't move addition through square roots or something like that. That's an operation that doesn't work for radicals. Okay? So we do have to leave it that way. Yes?
Could we put, instead of taking the 2 down, could we put a 1/2 in front of the integral and the 2's would cancel?
Say it again. I want to make sure I'm following.
So instead of putting the 2 in front of the integral, it would still be inside on top, and then
Yeah.
we put a 1/2 in front of the integral, and they would kind of cancel each other out.
Okay, so you want to know if I left this 2 here, whoops, and then what?
And then have a 1/2 in front of it.
But if you just introduce the 1/2, then you've changed the value.
Okay.
So this would actually have a different value than what the original one had.
So we would only have the 1/2 if, like, the du was...
You could have a 1/2 if you had, like, let's say, for instance, somehow down here, and you wouldn't on this problem because that's not how the completing the square would work, but if your du had a 2 in here that gave me a 1/2, that would introduce a 1/2 into a problem. So this would be a 2 here with divided to either side.
Okay.
Yeah, that's a possibility. Now you can still leave the 2 on top, like you suggested here, but you still get the same result, 2 in front, and then the arc sine stuff. Yeah. Any other questions? Okay.